Hi, my name is Heather Christensen, and today I'll be presenting on accessibility in data science, reconfiguring data into sound, a research project I conducted in the summer of 2021, funded by the Monroe Scholars Program at William & Mary. In this project, I focus on the field of sonification, the technical definition of which is the translation of data relationships into sounds that exploit the auditory, perceptual abilities of human beings, such that the data relationships are comprehensible. Basically, this means turning data into sound in a way that makes it easier to understand. This utilizes psychoacoustics, or the scientific study of how humans perceive sounds. In this case, the dimensions of sound, such as pitch, timbre, spacing, and loudness, are mapped to parameters of data. Sonification is useful because it can be used to reconfigure data to reveal new trends, present data in a way that is accessible to the visually impaired, and combat scientific jargon by presenting data through a universal medium, music. Some examples that you might be familiar with of sonification are the Geiger counter, in which the spacing of ticks are mapped to the number of ionization events, and EKG readings, in which the function of the heart is mapped to sound. The research question I came up with is what data set could be made more approachable through sonification? The data set I chose was insolation, or the energy absorbed by the Earth from the sun. Changes in insolation are influenced by the patterns in Earth's movement around the sun, which causes the squiggles you see in this graph here. The units of insolation are watts per meter squared, and these measurements are standardized by being collected from 60 degrees north in June. And each point in this bottom blue figure is 1,000 years apart. And what I noticed when looking at this data set is, wow, that looks a lot like sound waves. In order to sonify insolation data with the most flexibility, I use the coding program SuperCollider. This is a unique program in that the language and server are combined into one user-friendly interface. In this screenshot here of what you see when you open SuperCollider, you'll find at number 1 is SC Synth, which is the audio server. SC-Lang at number 2, which is the programming language that controls the server. And at number 3, SC-IDE, a built-in editor for the programming language with an integrated help system, which was incredibly useful as I had never coded before this project. This is a truly amazing platform for audio synthesis and algorithmic composition. I spent about 5 of my 7 weeks over the summer teaching myself how to code using the SuperCollider handbook and YouTube tutorials. This is a screenshot of my code in SuperCollider. A few important aspects of it are the buffer at the first star, which is a storage space for the data, the equation at the second star, which reconfigures insolation data, which is in watts per meter squared, to auditory numbers in hertz. Third star is the synth, written in SuperCollider code that is a computer instrument that plays the data. Fourth star is the equation used to balance the amplitude because in psychoacoustics, higher pitches seem louder and are thus interpreted as more important, so this mitigates that bias. The fifth star is the envelope, which is used to dictate a start, duration, and end to the synth. This was perhaps the most difficult part of the code. And here is a recording of part of this code being played. Future steps I'd like to take with this particular data set includes reversing the data to go forwards in time instead of backwards, which it currently does, and incorporating aspects of climate change research such as carbon dioxide levels from ice cores to possibly distinguish between cyclical and human-influenced climate change. The significance of sonification cannot be expressed in this slide. But moving forward, what I would like to do includes creating audio components for museum exhibits to make them more accessible to the visually impaired. I would like to work on sonifying complete data sets to enhance comprehension, particularly in the classroom where auditory learning is frequently overlooked. That's how I came across this data set actually, is I asked a lot of my friends in the geology department what data sets they were presented in one of their classes that just didn't make sense from looking at a graph. And finally, and perhaps most importantly, I would like to begin engaging with politically charged fields through sonification with the goal of reconfiguring data into a version more approachable to the general public. Thank you so much for your time. I'd like to thank the Charles Center for funding my research and Professor Rowan Lockwood and Nicholas Palacio for their guidance and support.